So far, we have seen Nyquist stability criterion and sums on that. Today, let us see relative stability using Nyquist criterion and M circles. M and constant M and N circles. This is Nyquist plot. This is Nyquist plot of third order type 1 system. We know. By using this, we can find the relative stability. Relative stability. Relative stability means we have to find the gain margin and the phase margin. To find the gain margin, we have to find where it intersects negative real axis. Say A. If it intersects at A, if it intersects real axis before -1, then it doesn't encircle -1. -1 plus J0. This is the point, -1 plus J0. It doesn't encircle. That's why the given system is stable. That we can tell. What is the relative stability? For that, we need the gain margin and phase margin. Gain margin equal to 1 upon modulus of A. 1 upon modulus of A is the gain margin in linear scale. Linear scale. Suppose you want gain margin in decibel scale, we have to find 20 log 1 upon modulus of A. Or minus 20 log A, modulus of A. That is gain margin in decibel scale, in dB. What is the meaning? If you suppose here gain is 0.5 means, what is the gain margin? Gain margin equal to 1 by 0.5, that is equal to 2. So, we can increase the gain by 2 so that the system will be in the verge of instability. That is gain margin. We can increase the gain by 2 so that the system will be in the verge of instability. That is gain margin. So 1 by modulus of A in linear scale. If you want tell in decibel scale, we have to take 20 log 1 by modulus of A. Suppose this plot goes like this. Here it intersects A1. Here the system is unstable because it encircles -1. Since P equal to 0, it encircles -1. Therefore, here, what is the gain margin? The gain margin will be less than 1 because it is A is greater than 1. Say 2. 3. Let us assume that it intersects at -3. -3. Therefore, gain margin equal to 1 by 3 modulus of A. That is 3. That is 0.33. It means if you reduce the gain by 0.33, the system will be in the verge of instability. So already the gain is greater than Kmax. Greater than Kmax. If you reduce the gain by 0.33, by the factor 0.33, then the system becomes in the verge of instability. If you further decrease, the system becomes stable. That is the meaning. But if gain margin is less than 1, linear scale, if gain margin is less than 1, unstable. Unstable. If gain margin is greater than 1, stable system. If it is gain margin equal to 1, marginally stable. Marginally stable. These are all in linear scale. Linear scale. What is phase margin? Phase margin. From Nyquist plot. What is the phase margin in Nyquist plot? Phase margin equal to, draw a unit circle. This is unit circle, -1, plus 1 plus j minus j. The Nyquist plot cuts the unit circle at A. The angle at that point is phi. Suppose say this is 135 degree minus 135 degree. Therefore, phase margin equal to 180 minus 180 plus phi, that is equal to 180 minus 135, 45. Therefore, the phase margin is 45. The meaning is, if you increase the phase angle further from minus 135 to minus 180, the system becomes the verge of instability. That is phase margin. So if you increase the gain, if you increase the phase further by minus 45 degree, then system will be in the verge of instability. That is the meaning of phase margin. That is the meaning of phase margin. So without adjusting the gain, we can make the system in the verge of instability by increasing the phase alone.